Here we have a rancher transporting cattle to another location. So we have a histogram that gives you the weights and then the frequency going up the side. So there was one cattle that weighed between 401 and 420 pounds. There were two cattle that weighed between 421 and 440 pounds, and so on. So if you add up all the frequencies, that sum is 30. Part B, 16 over 30, or 53.3%, or more than 500 kilograms. And then in part C, to find those values for the population mean, median, mode, you want to go to your calculator and press stat, and then edit, and then you can enter in your values across the bottom, which represent the weight in kilograms, and then the frequency into list 2. Now, because we have intervals, you want to put the midpoint of the interval. So the first interval that they give you on the page here, the 381 to 400, notice there's no value there. That's 0. So you don't even need to put that in. So the next interval, halfway between 401 and 420, to find that value, you can add those and divide by 2. And you can do that in your calculator. If you can't do that in your head, or it's not obvious to see the midpoint, what you can do is, in parentheses, you can do 401 plus 420, and then divide that by 2, and that'll give you 410.5. That's the midpoint. And once you do that for the first couple, you'll see that the midpoint keeps on going up by 20 each time, and you can fill the rest in that way. Okay, so your weights, the midpoint for your weights are in list 1, and then list 2 has the frequency for each of those intervals. So then to calculate the 1-var stat, so to find the mean, median, mode, press stat, calculate the 1-var stats. Oops, let me clear that so nothing is up there. So stat, calculate 1-var stats, and you want to do it on list 1, comma, list 2. Now if you have a different operating system, you might have X list and frequency. So list 1 is your X list, that's like your variable, and then list 2 is your frequency. So how many times that list 1 occurred, or the value in list 1 occurred. And that gives you the mean of 500.5. Now we know it's a population because they tell you that, so that's mu equals 500.5. The median, if you scroll down in that menu, it'll give you the median is 510.5. And then the mode, the one that occurs most often, well, the highest bar is this one, which is the interval 521 to 540, so you can write that as your answer, or the midpoint of that interval. And then the population standard deviation, sigma. So if we find sigma here, that's 41.55. You will never have to find the standard deviation by hand. You can always use your calculator, so make sure you know how to do that. And then part E, the probability that one of the cattle weighs between 441 and 500 kilograms. So when you look at your list, I'm sorry, your histogram, there's 11 out of 30 that fall in the interval. The second part I give you here is the same information in a different way. So now you have the weights again and the same intervals, except now you have relative frequency, or the probability, rather than the actual frequency. So this makes it a little trickier. So what you can do is you go to your calculator, okay, press stat and then edit again. And you want to put in the midpoints again. So do that exactly the same way as before, except now If we don't know the frequency, but we know the relative frequency, you can take your bar graph and estimate what it is there. Now it looks like that one is about 0.03. So you would put 0.03 in for that first value in list 2. And then the next one, it looks like, well, it looks like it might be about 0.07 or 0.06, somewhere in there. So you could enter that in. And then you do the same directions as before. Stat, calculate the 1 bar stats, and it'll give you the same answers. If you had the list of values, whether it's in a frequency distribution, so you had the interval listed with its frequency, then you could actually put 1 out of 30 in that first one, and then 2 out of 30 in the second one. So what I mean by that is, rather than try to guess from the height of the bar, because that's really estimating what it is there. I'm estimating that it's 0.03. If you had the knowledge that 1 was the number in the first bar, then you could say 1 out of 30. And that'll give you the 0.033 repeating. The next one had 2 out of 30, so do 2 divided by 30, and so on. That's if you knew the actual frequency in each of them. Otherwise, you have to estimate based on the height of the graph, and you may not be as precise that way. But that might be all that you're given, so you just got to be careful with that.